A common problem with external validity of empirical work is related to scaling. Once you start to roll out a program on a broader basis, then generally speaking, the treatment effect goes down. This is what we call voltage drop. There's two reasons why this should be so. First of all, treatment fidelity, and the second one is general equilibrium effects. What is treatment fidelity? That relates to that is the extent to which an intervention is accurately implemented. Usually speaking, when you conduct a randomized controlled trial, then you make sure that everything runs as planned, and you select employees carefully so that they really administer treatment as it is supposed to be, i.e. The people running the experiment may not be representative of what to expect when you roll out the same treatment region-wide or nationwide. It may well be that when you scale up, that you have less devoted personnel or less skilled personnel. And personnel is absolutely key, because in social programs it's usually human beings running the show, right? So labor is really a key input. Think of health interventions, so nurses, or in education we talk about teachers, or in crime, it's about police officers. And the underlying problem here is, if you scale up and you need allow people to run this program, then there's going to be competition for scarce labor. And if you have limited resources, then it may mean that you will have to hire employees that are a little less skilled and also a little less devoted, just to make sure that the treatment is actually administered. So generally speaking, if you scale up the treatment, then you should expect a lower effect of the treatment than in the case of this carefully run randomized controlled trial. A second reason for the so-called voltage drop are general equilibrium effects. What we mean by that is that there may be spillovers from treatment to control, and there may also be spillovers actually from treatment to treatment. Look, if you look at the graph, so in a randomized controlled trial, we make sure that there's a clear distinction. So we have treated units and we have control units, and the implicit assumption is then SUTVA, remember from Econometrics 1, no spillovers. But that may not hold in practice. Usually subjects are connected by way of social networks, and they may share knowledge, they may share resources, or they may compete for the same resources and all that. And as a result, the difference between the two means, the difference in the outcome for the treatment group and control group, may not reflect the true treatment effect. For instance, when treated units affect control units positively, then the difference in the outcomes between treatment and control becomes smaller, right? Because not only treatment goes up, right, that they do better, but control does also better. So if you then take the difference, then obviously that difference is going to be smaller than in the absence of spillovers. In the extreme, the treatment effect may actually go to zero. And so you may actually conclude that the treatment does not do much, but that may be solely the result of not accounting for spillovers. And the more you scale up, the more likely those spillovers are going to be. A nice example in the labor economics literature is a study by Peter Gauthier and others. They look at intensive guidance of job seekers, and supposedly that this has a positive effect on their chance of finding work within a short time span. And that is also what the randomized controlled trials show. They show a clear positive effect of intensive counseling of those job seekers. However, Peter Gauthier et al. Then also collected data for job seekers in counties that were outside of these randomized controlled trials. And what they find is that those job seekers actually had a lower chance of finding work, i.e. the treatment has a positive effect on treated job seekers within treatment regions, but it has a negative effect on job seekers that were outside the original randomized controlled trials. So the original randomized controlled trials overestimated the effect, and if we would roll out this treatment, this intensive counseling to the whole country, then maybe on the net we don't achieve much. So they say if we roll out this treatment, then maybe all that is going to happen is that there's going to be lots of search costs because we help them searching for work, but they're competing for the same job. So in the end, who knows? The unemployment may actually even go up, right? So this is one example of negative spillovers leading to overestimation of the treatment effect, and also implying that when scaling up this program, the average treatment effect is likely to be much lower. The opposite may actually also happen. There's a nice study by John List et al. They look at an early childhood intervention program in one of those Chicago neighborhoods with many low-income families, and there's many of them. This intervention was aimed at 3 to 5 year olds, and the randomized controlled trial of this program showed sort of modest effects. So not, positive, but not spectacular. But then List et al. Look at how the treatment also led to spillovers, and they find that those spillovers are actually substantial. So treated children influence other children positively, and other children may be either other treated children, or also, and that's the problem, control children, children in the control group. So, and then they actually account for spillovers, and they impose a model on those spillovers, assuming that the spillovers get smaller with distance. And then they find that in the original randomized controlled trial, the effect was greatly underestimated. So the broader lesson here is that it may not be enough to simply randomize subjects into either treatment and control and then look at the difference of the means, but you should also think about whether those subjects are connected by way of social networks, and as a result, there may be spillovers, and you may either over or underestimate the treatment effect. As soon as you relax the assumption of no spillovers, then you will have to make new assumptions about how those spillovers actually should be modeled. Oftentimes spillovers are assumed to be a function of distance, a linear function of distance, but that may not be true. For instance, if subjects in the network communicate by way of social media, then obviously distance, physical distance, may be a poor approximation of how spillovers actually occur, right? If spillovers are indeed a function of physical distance, then if you do want to run a randomized controlled trial and you don't want your estimated effect to be greatly affected by spillovers, then you may want to include buffer rows so that those social networks do not overlap and that treatment really only affects the treated subjects and not also the control subjects. One note, in economics we are very much used to decreasing returns to scale, and why should this also not hold when we look at our treatment, our policies, right? So it's usually if we broaden the net of a treatment, then we may actually catch other subjects, and so and as a result, the marginal effect of the treatment may go down. Oftentimes, treatments are first targeted at those who need it the most, and that makes sense. Then the marginal effect is the largest, but if that is true, it also means that those subjects that get treated first, for those subjects it holds that there is a large marginal effect. But once we start scaling up, then we are also going to treat subjects that do not need the treatment as much, i.e. the difference between treatment and control goes down. Actually, I did a study on the effect of locking up habitual offenders for a longer time, and that had large effects, but I also showed that the police went after the most prolific offenders first. So then obviously the number of crimes that did not occur thanks to incapacitation was huge, but then over time the police also started offenders that were less prolific. They did not commit as many crimes per day or per week. So the incapacitation effect, the effect of not being able to conduct a crime when incarcerated, also went down.